Hello everyone, this is Mr. Trujillo. We are going to be looking at equivalent ratios or equivalent fractions as you might know it. Uh, First of all, let's start with uh, a, a fraction like this, or actually any number. When you multiply it times 1, you always get the same number. And that's the main idea when you are working with equivalent fractions. If you multiply 1/2 times 1, your answer will be 1 over 2, which is 1/2. As you can see, 1/2 is 0.50 hundredths, and this is 50 hundredths. So you get basically the same answer. The value is still the same. That's the idea when you are constructing equivalent fractions. If you have 3 over 4, your answer will be 6 over 8. Why? Because you're multiplying it times 2 and times 2, numerator times 2, denominator times 2. So 3 times 2 is 6 and 4 times 2 is 8. And this 3 over 4 and 6 over 8, they are both equivalent fractions. Why? Because basically you're multiplying them by 1. This 2 over 2 is actually a 1. 2 divided by 2 equals to 1, right? And you can prove it by doing a long division. If you divide 3 divided by 4, you will get 75 hundredths. And if you divide 6 divided by 8, you will get also 75 hundredths. That's a proof to see that this here and this 6 over 8 are equivalent fractions. So let's see another example. This 2 over 7. This 2 over 7 has an equivalent fraction or has infinite equivalent fractions, but this is one of them, 6 over 21. Basically, I multiply 2 over 7 times 1, but that 1 is 3 over 3, so it's 2 times 3 equals to 6. 7 times 3 equals to 21. And I get the same value. I use the calculator to put 2 divided by 7, and I get 2,857 10,000ths. And the same thing with 6 over 21. My answer is 2,857 10,000ths. Uh, the same value. Why? Because they are equivalent. It also works with division. Division, do 15 divided by 15 equals to 1. 30 divided by 15 equals to 2. As you can see, this is a 1. When you divide a number by 1, you also get the same value. 15 over 30, its value is 50 hundredths. And 1 over 2, or 1/2, is also 50 hundredths. It works both with multiplication and division. It does not work with addition or subtraction. Addition or subtraction will be something different. Take a look at this. If I add plus 1 plus 5 over 5, 1/2 plus 5 over 5, I'm actually adding half plus 1, which is 1 and 1/2. This is 5 tenths or 5 hundredths or 50 hundredths, I'm sorry, and this will be 1 and 50 hundredths. So it doesn't work with addition and subtraction. You can only use multiplication or division to get equivalent fractions. Okay, there is a way for you to test for equivalency. So let's start with our first example. 1 over 2 equals to 1 over 2. Uh, Only and only if you multiply this 1 times 2, 1 times 2, 1 times 2 equals to this 2 times 1. As you can see, 1 times 2 is 2. That equals to 2 times 1, which equals to 2. They have the same, you come up with the same answer. Let's test example number 2. 3 over 4, we said is equal to 6 over 8. That is true. This is 3 times 8 equals to 4 times 6. 3 times 8 equals to 24, and 4 times 6 also equals to 24. So they are equivalent fractions, right? Let's look at 2 over 7 equals to 6 over 21. If you cross multiply, you're going to find out that this 2 times 21 equals to 7 times 6. This equals to 42, and this equals to 42 as well, right? Last one, 15 over 30 is equal to 1 over 2, because 15 times 2 equals to 30 times 1. This is 30 equals to 30. As you can see, when you have equivalent fractions, you can test it and multiply, cross multiply, to see if they are equivalent. Okay, that property we're going to be using because now that becomes predictable when you're missing a number. For example, if you look at this problem right here, 1 over 3 equals to something over 15, I'm missing a number right here. But knowing that property, that when I multiply like this, 1 times 15 equals 15, when I multiply, I'm multiplying 3 times something equals 15. There's only one number that goes here. That will be number 5. So this is number 5. I was missing number 5. Same thing with this. If I'm missing this other number, right? 3 times 6 equals to 18. If I multiply this like this, I get 18 when multiplied. Then 2 times something has to equal to 18 as well. So what number am I missing? Well, the missing number is 9. Now we're going to be using this property of equivalent fractions to be able to solve problems. Problems such as this problem that has 300 over 6, right? I'm missing a number, and I have a number right here. What's the number? Something over 2. Well, this could be a problem related to miles per hour. If I drove 300 miles in 6 hours, how many miles did I drive in 2 hours? And this is very simple now, because 300 times 2 is 600, right? And 6 times what equals 600. Well, the only number that goes there is the question mark will have to be 100. Right? We have this percentage problem. 20% is also an equivalent ratio. This 20% is missing something here. But I know that this is the same thing as this. So 2 times 4 is 8, and I add us 8,000 like this, 8,000. 100 times what equals 8,000. If I put 8 right here, that will be 800. So it has to be 80. So 80 is 20% of 400. So we are going to be using this equivalent ratios properties to be able to solve problems. And that we're going to be learning other skills to be able to solve this, but we'll also take care of these problems like this that have to do with unit rates. These problems will also be able to solve like this. If you multiply like this and you multiply like this, you should know what this is, right? So thank you so much, and we'll have us another video to do some of these examples. All right, thank you so much.